Hello students, today we will be doing with the types of vectors. We have already started with the class on vectors. Last class we had done with the parallelogram law of addition of vectors and triangle law of addition of vectors. Today's we will be doing with the types of vectors. When we talk about the types of vectors, but there are so many types of vectors, okay? So let us see one by one all the vectors, and we'll try to understand how they are expressed, how they are connected. Let's start with the first vector, which we call the axial vector. We start with the axial vector, types of vectors. Axial vector. The name itself is very convenient. Very simply, way this name is giving an indication that when we have a vector, when we have any of the physical quantity and it is not along the same straight line, but it is along a certain axis, then we call this as the axial vector. What could be the example of this? We can have angular velocity. So example can be angular velocity. Then we can have torque. Then we can have angular momentum. All these things will come under this category. Next, let us talk of polar vector. Let us talk of polar vector. Polar vector. Now in polar vector, when we have a physical quantity and it starts from a specific point, you can locate that particular point. It has got some starting point. Then we call this, and that is again in a straight line, we call this as the polar vectors. And then again we can have so many examples here. We can have displacement, we can have velocity. All these things, examples will come to this. Displacement, velocity, etc. Now let us take few more. Let us talk about position vector. When we talk of the position vector, then we need the origin. Suppose if we have got this as the axis, this is x, this is y. Let us assume this is one vector A and this is another vector B vector. Now in this is the origin. Let me write this as the origin. So when we talk of position vector, the word which is connected to it is origin. So any vector which is linked up with the origin is known as A vector. It's known as position vector. In the given figure, A vector is the position vector, but B is not a position vector because it's not linked up with the origin. So A is the position vector. If I can draw any vector and then let us assume C vector, it is a position vector. But if I write any vector like this, it is not a position. This is not position vector. This is not position vector. So if you recall, if there is a position vector, what is very important? The origin. So look for the origin for the position vector. Okay. Now let's do with the co-initial vector. Co-initial means any sort of vector, they have the same initial point. It simply means you have got so many vectors and the starting point is same. We have co-initial vector. So suppose if there is, this is A vector, this is B vector, this is C vector, but then again if I have any vector represented as D vector. So what you find that here A vector, B vector, C vector are co-initial vector, but D vector is not a co-initial vector because their starting point is not same. So you have to see that they arises from the same initial point. When you see the vector, you just see that they are arising from the same initial point. Then that is the reason it is not termed as co-initial vector. Okay. Then we have got coplanar vector. We have coplanar vector. Coplanar means lying on the same plane. Coplanar. Suppose if we have taken xy axis, this is xy axis. The vector is lying here, it is coplanar. Let us assume this is coplanar. This is coplanar. So they all are lying on the same plane of xy plane. But suppose if the vector is lying somewhere here, then it is not lying in this particular plane. It is not lying in the plane of xy, but it is lying somewhere else. So that is non-coplanar vector. Okay, so these are the different types, but one of the vector definitely I would like to do, that is what is the unit vector, because unit vector becomes very important for you to understand, and once you understand unit vector you can express any vector in terms of this. Okay, so let's do with unit vector. There are equal vectors, there are negative vectors. Equal vectors means they have the same magnitude and they are in the same direction. Equal vector means they are in the same direction and they have got the same magnitude. Same direction, same magnitude. And there can be so many vectors. Okay, there are zero vector, null vector also. So they have the magnitude as equals to 0, but then again its magnitude is 0, but then again it has got a certain direction. Okay, so we are talking about, we are interested for the unit vector. Unit vector. Now when we talk of unit vector, we will take a 3-dimensional. It simply means we'll take x-axis, we'll take y-axis, and we'll take one more axis, z-axis. So when you have any vector, you can, when you visualize this x, y, z axis, better you see the corner of your room. When you see the corner of the room, then you can very well understand what exactly I am talking about. When you see the corner of the room, then what you really find, that suppose I have got I can hopefully I hope you can see this. So here if I take this as the origin, I am taking this as the origin, this I can take as x-axis, this I can take as y-axis, and this I can take as z-axis, right? This is a straight line just going up. Same way, if you see the corner of the room, you can very well visualize. So this is the way, this is the origin. So here you have got x-axis, here you have got y-axis, and this line will give you the z-axis. And you can very well understand they all are making an angle of 90 degrees with each other. So when you have this, if you have, you can have how many planes? You can have xy plane, you can have yz plane, you can have xy plane, planes that we have, you can have xy plane, you can have yz plane, and you can have zx plane. So you can have 3 different planes, right? And unit vector is those vectors which has got magnitude as 1, but it is important because it helps you in giving the directions. Okay, so the direction for x-axis, the unit vector that we take along x-axis, unit vector along x-axis is equals to I caret. Similarly, unit vectors along y-axis is equals to, we take j caret, and unit vector along z-axis is taken as k caret. So it simply means along x-axis, if we talk, this is our origin, I will take it as I caret, this is j caret, and this is k caret. So this is the how we represent the vector. Although I caret is having the magnitude as 1, j caret is also having the magnitude as 1, k caret is also having the magnitude as 1. Okay. Now what is the significance? How we are representing it as a vector? You have done in mathematics the coordinates. The coordinates, you know it very well. Okay. So when you know the coordinates very well, let us see what we can have. We can have a condition. We can have a condition. Let us take, we are talking about xy plane and there is a coordinate. Let us take a position vector, r vector, and its coordinate is x comma y. Fine. So coordinate, it simply means till your distance is x and till your distance is y. So how you can represent this r vector? You can represent this r vector as equals to x I caret plus y j caret, right? And the magnitude, if you want to find out, if you see, this is magnitude. Pythagoras theorem, this is x square plus y square. X square plus y square. Magnitude ka whole root over. This is the magnitude. Or simply r is equals to under root of x square plus y square. Fine. And if you want to find out the angle, then you know tan theta is equals to y by x. Clear? Suppose if you get a vector as equals to 3I caret plus 4j caret. Then the magnitude, you can very well write this as equals to 3 square plus 4 square, this is under root 9 plus 16, so this 25, so it comes at just 5. And then what will be the angle? Tan theta. Tan theta will be, this is for y, so it is 4 by 3. So this is how you do with vectors. This is how you do with vectors. So you have to be very confident. This is the 2-dimensional I have taken, but in the 3-dimensional also you can take the same value. You can just write it in that way, so that, and then you can very well write in the component form also. Okay, because along the x-axis it is r cos theta, along the y-axis it is r sin theta. So this is in the component form also. The magnitude you can write. Suppose if you want to work with angle, then x will be what? Here it will be r cos theta, and here it will be r sin theta. Then you can very well write in terms of angles also. You can write in terms of the coordinates which has been provided to you. So make sure that you become very comfortable with this ijk, because once you become very comfortable with ijk, then definitely you can do more and more and more scalars and vectors product, because the next coming up class will be based on the dot product followed by the cross product. Thank you for watching the class. I hope you have understood it. Thank you. Bye.